So as Mr. Roy just mentioned, for the next, I'd say probably the most of the term, okay, the next 3 academic weeks, we're going to be looking at solving systems. So there's different ways to solve them, and which way you solve it, we try to pick the easiest way. Graphing, I don't think it's the fastest way to do it, but it is okay to use it, especially if you already have y by itself. Okay, so we're going to be looking for things today like y equals mx plus b. We're going to be graphing, and we're basically going to be looking for where 2 lines cross each other. So instead of just doing like you did in the warm-up, okay, where you had one line, well, we're going to be graphing another line at the same time, and the goal is going to be to figure out where they cross. Okay? If we can figure out where 2 lines cross, that's all we have to do.
You guys remember, from now, next academic week, the academic week after that, when we're answering these type of problems, we're always going to have 2 answers. We're always going to have an x equals, we're always going to have a y equals, because there's always 2 variables in each equation. We're always going to have an x and we're always going to have a y.
All right, so on your notes, the first thing in bold, it says A, and then you have a blank. You want to write down system of linear equations. Okay, and the systems that we're going to deal with are always going to have 2 letters and, yeah, that's it, 2 letters to solve. Okay. Some systems get more complicated, like we just have an x and a y. Sometimes you have an x, a y, and a z. Okay, you have a 3rd letter. You guys won't see problems like that until probably Algebra 2. Right? So for us, we're always going to have to solve for 2 variables.
That was a blank on your guided notes too. Right in number 2.
Okay, so that means when you solve a problem, every problem we do this week, you should have x equals and an answer, y equals and an answer. Okay, there should be 2 answers to every problem.
Let me say, are we going to want them to write it as like a coordinate, like 2, 5?
When we graph it, yeah,
Yes.
because it's an intersection. Yep. All right, so an example Mr. Roy already showed you. I'll write down one we'll look at in a little bit.
Let's go back to that. So Mr. Hager's going to write one. All right, there's his linear equation, x plus y equals 7. Can somebody else give him another linear equation? Listen, I don't care what numbers you use. I want you to use x and y, but I don't care what numbers you use. Somebody come up with another linear equation? Well, just try to use some different numbers, Jody. Shannon?
2x plus 3y equals,
Whatever you want. Whatever you want.
1 million.
6.
6. Right? Anything like that will work. I could say, I didn't have to do it in the same order Mr. Hager did. I could have put it in slope intercept. I could have done y equals 3x plus 2. I could have done 3x plus y equals negative 5. I could have done 3 equals 5x plus 2y. Any of those things will work. All right. Anyway, it doesn't matter how you do it. As long as you have x and y, an equal sign, and nothing funky going on. No exponents, nothing like that.
Yeah. So in general, we're going to use the letters x and y, but when we do a word problem, like let's say you had a problem about like, sometimes we do problems with fruit, like we're buying apples and bananas. Maybe you'd want to use A for apples and B for banana. But for most of the problems that are not word problems, X and Y. Okay. All right. So a solution. Okay. On the next, on your next blank, a solution. Okay, of a system of linear equations with 2 variables. It's basically a coordinate. Okay, the solution is a location. It's a spot on the grid somewhere. And we're trying to find that spot. And the way we're going to find it is we're going to draw 2 lines. They're going to cross each other. And Mr. Roy and I are going to make it so they cross at a nice point. Okay, they're not going to cross at like 2.7, comma 9.6. Okay, they're going to cross at nice numbers. Yep, whole numbers. Because if they're crossing at decimals, you really can't tell that by graphing by hand. Okay, so a solution of a system of equations in two variables, it's an ordered pair, or a coordinate, that satisfies each equation. Somebody give me two numbers that add up to give me 7. Any two numbers.
3 and 4.
3 and 4. So if x is 3 and y is 4, it works here. But they also have to work here. Let's try
They're
it.
working both equations.
What's 2 times 3?
6.
Plus, and you said y was what, 4? What's 3 times 4?
12.
Does 6 plus 12 give me 6? No. So the numbers that she picked, they worked in the top, but they didn't work in the bottom. Okay, we have to find one that works in both. Okay? All right, so the first kinds of problems you're going to look at, they're going to give you a solution. They're going to say, is this a solution to the problem? And you're just going to write yes or no. All right, so.
They're gonna write that piece that's covered up.
Okay. So to determine if an ordered pair is a solution, what you're going to do is take what they give you and plug it into each equation. If you plug it in and you get a true statement, then it works. Okay, so like Vanessa gave me the 0.34. I plugged it into the top one. Yep, I checked it off. It worked fine. But when I tried it in the bottom one, it didn't work. So what that means is 3,4 is not the solution. Okay, it has to work in each equation. Okay, and this is especially important when you're graphing, because a lot of times you want to check your answer. Because graphing, if you're not careful, you might be off a little bit. Okay, because we're not really using any algebra today to solve it. We're just drawing a picture. So you really want to make sure you check your answer if you don't use algebra. Okay, if all you're going to do is draw a picture, double check that you did it right. Okay, does everybody have that step? Plug the ordered pair into each equation. All right, so let's try a couple. And what they've done here is they've given me these two equations. What do we call these again? This is a, what's the name of that when they give you two equations with two letters? It's a system. Okay, so they gave me a system. They're asking me if you plug in 2, 5, does it work? Okay, so let's try it. Let's just start by identifying what's x and y in the point 2, 5. Kyle? The 2 is x and the 5 is y. Which equation do I have to check this equation in? The top? Do I have to check this point in the bottom? Or do I have to check it in both? I have to check it in both. So we're going to replace x with 2. We're going to replace y with 5. I'm going to put a question mark because that's what I'm checking.
And so guys, on your notes, you didn't have that system on there. So you need to write the system in. The x plus y equals 7, and the 2x minus 3y equals negative 11. You need to make sure you write that in on your guided notes.
Okay, so does that ordered pair work? Does it satisfy the first equation? What do you think, Liam? Yeah. If you plug in 2 for x and 5 for y, they do add up to give me 7. So when it works, you're going to get the same number on the left and the same number on the right. Okay. So does that mean this is the answer to the problem? No. What else do I have to check, Kyle? I've got to check it in the bottom one. Okay. Right now, I only know that it works on the first one. Okay. Let's check the second one. How about Antonio? What am I going to fill in for x here?
2.
Yep. And how should I do it? So, because if I just put a 2 in for x, it would look like the number 22.
But like circle or like
I heard somebody say put the times symbol, like a dot. You could do
I
that.
meant like the dot between the 2 and the 2.
You could do the dot, or I heard parentheses. Parentheses probably a good way to do that because we're going to look at that more tomorrow too. So put parentheses around whatever you plug in. Okay. And Sabrina, what am I going to replace y with? 5. I'm going to put a question mark because I don't know if this is going to be true. Okay, let's check it. Natalie, what's 2 times 2? Gives me 4. And Maggie, what's 3 times 5? 15. All right, now if I do 4 take away 15, Iselise, what's 4 take away 15? Well, think of it as 15 minus 4, and then switch the sign. Yeah. So 4 minus 15 is negative 11. I got negative 11 on the left. I got negative 11 on the right. So did this point work in the bottom equation? Yeah. Did it work in the top equation? Yeah. So tell whether the ordered pair is a solution. Yes. It is a solution. In fact, it's the only solution. You couldn't come up with 2 other numbers that would work in both. That's the only one that would work. And when we draw this, you'll probably see why. Okay? Think about if you draw 2 lines. How many times can 2 lines cross each other? They can only cross one time, one spot. If you were to draw these on graph paper, where do you think these 2 lines would cross each other? What coordinate? Where? Where do you think these would cross each other?
Think about where they.
Son? Don't think too hard. It's right on the board.
Y would be 7 when you go up and then across 11.
So what's the solution to this problem? What was the answer they wanted me to check?
What
No.
numbers did you plug inside?
Oh, you plug in. You plug in 2. I don't know why.
Yep, 2's good.
2, 5.
And when we plugged these numbers in, what did we find out? That 2 comma 5 was what?
Cross it 5?
It was did somebody say it? This is the solution to the problem. 2 comma 5. So if I were to draw these lines, that's where they would cross, the point 2,5.
We're working backwards right now, guys.
In the future, you guys are going to have to figure out 2 comma 5.
You'd have to graph those 2 equations and then figure out where they cross. So now we're telling you where they cross. We're giving you that coordinate 2 comma 5, and you got to work backwards to check it.
Okay, so here's another one. Maybe this is the solution. Maybe it isn't. We're going to check and see. All right, somebody walk me through the steps. How do I see if that is a solution? Antonio?
Plug in -2 where the x is. And
Yep.
0 where the y is.
Okay, so I'm going to plug in -2 for the x and plug in 0 for the y. Can you do that in the top equation and tell me what I get?
You get positive 4 minus 4 equals 0. So
And what do you start with? What's the first thing?
Fill it in.
0.
Yep, 0 equals.
4 minus 4.
And how'd you get 4?
-2.
You were right. I just want to know how you did it.
-2.
Negative
Positive 4.
2 times -2. Perfect. And go ahead. What did you say? -2 times -2 was.
4.
And what's 4 take away 4?
0.
Yeah. So does that answer work in the top equation? Yes, it does. Does that mean it's the solution to the whole problem?
Yes. No.
Not yet. We don't know. We got to check it in the bottom one. All right. Can somebody tell me how I check it in the bottom equation? Kyle? Yep. Plug in 0 equals, what did you say for x? Negative 2 plus 4. And can you finish that off for me? What's negative 2 plus 4? 2. Does that answer work in the bottom equation? No. 0 does not equal 2. 0 and 2 are not the same number. So what does that mean about the coordinate negative 2, 0? It's not the solution. If you were to draw these two lines, they do not cross at negative 2, 0. They don't cross. So no, that is not the solution. Okay, and if that happened when you graphed it, you checked it and it didn't work, then that would mean you made a mistake graphing. Okay, and, well, actually, let me ask you something first. If we check a solution and it doesn't work in an equation, let's say the first one, do we have to check the second one? Why don't you have to check the second one?
First one is better.
So we're saying if you check it in the first one and it doesn't work, do you have to check the second one? Why not, Josh? Yeah, the first one already doesn't work. It has to work in both. So if you check the first one and it doesn't work, you can stop. It doesn't matter if it works in the second one. It has to work in both. Okay? All right, so last one, and then we'll get into some graphing ones. Okay, the last one we're going to do today is a word problem. That's probably the toughest because you have to figure out the equations yourself and then solve it. Okay, but we'll go through that. All right. Jordy, can you tell me how I figure out if that is a solution?
I don't know.
Well, what is this? What do these two numbers represent? Like, what's the 1?
X.
That's x. And what about the 4?
Y.
That's y. All right, so what am I going to do with the 1 and with the 4? I got to do something with them to check if they work in this equation. How do I check if they work? Yeah, we got to plug it in. Right. So I'm going to change, how about, Hannah, what am I going to change y to? 4. And what about x? 1. So can you read to me what the right-hand side will say after I do that? Yep, the 1 in parentheses. And then plus 1. 3 times 1 gives me, and what's 3 plus 1? 4. So does that point work in the top one? Yeah. Perfect. So am I good? Can I just say, yep, that's the answer? No. I got to check and make sure that it works in the second one. Okay, so Ashley, can you tell me how I set it up for my bottom equation? Okay. Plus 5. So the question, what is negative 1 plus 5? Yeah. Yep, that gives me 4. So did that point work in the bottom one?
Yeah.
Yes, it did. Okay. So the answer here is yes. So now if we drew these two lines, which these would be easy to draw, right? Why would these lines be easy to draw? Compared to like example A. If you get something like example A, that's more of a pain to deal with. Example C is a lot easier. How come? Yeah, it's already in y-intercept form. Okay? So if you were to graph these, where would these two lines cross? At the point 1, 4. Yep. Okay, so any questions on kind of working backwards? If they give you the answer, how you check and see if it works? All right, so now let's try it the other way. This part I already said to you, and
It wasn't on there, and it wasn't there.
yeah. So the coordinate that we found that worked, that's where the lines cross. Okay, so my question was going to be, how can you have a line, two different lines, like this, and have a coordinate that's on both of them at the same time? Well, the only way you can have a coordinate that's, let's call that line A, let's call that line B, it would have to be right here. That point that I just drew is on line A and B. And the only way that can happen is if it's where they cross. Okay? Is there any other way I could have a point on both lines at the same time and it's not where they cross? Is that possible? Kyle? What do you think? No? No, you can't. If you put a line, put a point anywhere else, that's on line A, but it's not on line B. Okay? That's on line B, but it's not on line A. Okay, the only way you can have a point on both at the same time if it's where they cross. So we mentioned that. And then this part, I think you have this on your notes.
So you want me to do this part?
Sure.
So guys, we're going to solve systems by graphing. All right, like we talked about, there's three methods. Graphing, we'll do today, substitution for the rest of the week after this, and then elimination next week. So if we're going to solve by graphing, first thing we're going to do, we got to graph each. All right? We're going to graph each equation. One thing I want to add, make sure that the equation that you're going to graph is in y equals mx plus b form. And we just talked about, that's why we did the warm-up, is how to use that slope-intercept form of y equals mx plus b, how to use that to graph. That's why we did that in the warm-up. So on the back side of your sheet, you have 1, 2, 3 numbered with blanks. So on that first blank, you want to write in, graph each equation, make sure it's in y equals mx plus b form. You want to do that right here. Right next to number 1.
So why don't we do one graph and then go to the word problem, and then if we have extra time, go back to the other graph.
Yeah, 'cause we can even do the other graph as like a practice too. So like I said, make sure it's in y equals mx plus b form. You might get a y, like, okay, let's look at I know they're hard to see, but I got y equals 3x plus 2. Is that all set to graph, yes or no? Is this ready to graph? Y equals 3x plus 2, am I all set to graph that? How many people say yes? How many people say yes, that's ready to graph? Raise them up. How many people say no? You didn't vote, Dominic. You say yes? All right. I agree with you. Why do I agree with you?
I'm sure I just guessed.
Okay. Someone else that said, Nina, you said yes. Why? Okay, that's fine. But it follows the format, right? Remember, it's y equals mx plus b. All right? The y's first, the y's first. Equal sign, the number with x, all right, is there, and then I just have a number at the end. This one right here is all set to graph. I could graph that. The next one up here, I got 3x plus y equals negative 5. Is that all set to graph? No. Who says no? Ashley, why?
It's not in the plan.
What's in the wrong place?
The Y.
Well, I got the y. I got the y. I got the
It's
y.
in the wrong spot. It's supposed to be in the frame. So it's not-
Okay,
It's not like how it's supposed to be written.
I agree with that. What's in the wrong spot? So I got 3x plus y equals negative 5.
Oh, 3x.
That's a mistake is written on the board right now. I absolutely agree with you, Ashley. The 3x is in the wrong spot. All right? The 3x is in the wrong spot. What do you have to do?
Move it.
How do you move it?
And then use 3x.
minus 3x, right? So we'll subtract 3x. So now I'm going to have y equals, what should come after the equal sign? The negative 3x is a number with x, or the slope has to come after the equal sign. Negative 3x, and then the last thing should be what? Minus 5. Now that's in slope-intercept form. So in that case, this problem, the x is in the wrong spot. A lot of times you're going to get this. The x is in the wrong spot, the x comes first. Give it the opposite sign, move it to after the equal sign. All right? And then this last one is also in the wrong form. All right? We got stuff like all over the place. All right? But I'm not even going to go through that right now. So we're just going to make sure it's in y equals mx plus b. All right? So now, once we graph our two lines, all right, we're going to estimate the point of intersection. All right? So in my answer, what should it look like? What should my answer look like? Huh? Not x equals y equals, careful.
You could, that's okay.
You could do that. All right. What's another way we could do it? Huh? You do it as an order pair. What's that look like, Kyle? Yeah, I could do parenthesis. Whoa. Whoa. There we go. Something like that. All right. What letters here? X, and then I have y there. So that's another. That's for doing what we're doing probably tomorrow and with the elimination stuff. X equals y equals is good. It's not wrong for this, but this form is probably a little bit better because it's an actual coordinate. You're not wrong, though, Kyle. All right. So we'll look at our graph and see where they cross. What point is that? Remember, we look at the x first, and then go to the y. See what it is. See what it is on the x-axis first. See what it is on the y-axis next. That point is going to be where it is. All right. Then we'll check our answers. All right. We're going to plug the x in, whatever number x is, into x in both equations. We're going to plug whatever number y is to the y in both equations. And we'll check. Remember, if it doesn't work for the first one, then don't keep going. Don't do more work than you need to. If it doesn't work for the first equation, it doesn't matter. Because both numbers have to work in both equations. All right? And like the same thing, we did that in example. We just did that in example 1. Basically what we did in example 1, and those 3 different ones we did, we practiced checking. We got the coordinate, we had to plug it in and check if it worked or not. Like I said, we were working backwards. We got the coordinate, we had to check. All right? So those are the 3 steps. We'll graph it, make sure it's in y equals mx plus b, estimate where it is, find that coordinate where it crosses, and then we'll check it by, like we just did. But we have to, basically what we're doing now is we have to find where that number that we gave you in the first example, we have to find it now by graphing. All right? Is everybody good with this? Everybody's good with this? Yes? Yes? And you don't have to write this, we did this in example, unless you want to. What's up, Sam? Say again? I don't. No. I don't, kid, I'm sorry. If you can go to the nurse if you want. All right? Solve the system by graph. So this is what we just talked about. First thing we got to see is, we got to see if we can graph it. So what needs to happen to be able to graph it? What needs to happen to be able to graph it? You can tell me. What needs to happen to be able to graph it? We just talked about this. Come on, guys. Go ahead, Bay.
This should be in y equals mx plus
Y equals mx. Look at the first one. Good? Second one? Yeah, they're both good. Y is first, then x, then a number at the end. We're fine. All right? Now, we'll graph that first one. Someone tell me about raising their hand and graph that first one. How do I do it? How do I graph that first one? How do I do it? Josh? Starting the y-axis? That's the vertical one, right? Okay, then Where do I go? What number am I graphing on the y-axis?
5.
5, right? So Mr. Hager's going to go up 5, right, on the y-axis? Okay, cool. So we did that. Now what, Josh?
Make the negative 2.
Put that over 1, okay? Mr. Hager's going to do that. He's going to put that over 1. Now what?
Go over to the right one.
Careful.
Go,
I like what you're doing that. I like that.
go down to.
Down to,
Over.
be more specific with your over.
Over the right.
Right. Remember, we're only going to treat the top number as if it's negative. Always go, if slope is negative, go down to the right. Never go down to the left. I've said that 100 times before. Down to the left, down to the left. And then, if you want to, just keep going. All right? Just keep going down. You want to try to cover the whole graph because you want to find that point of intersection. All right? Maggie, do you think on that bottom one, you might be able to tell us where we would start our graph? Like for this one, right? We put a point at 5. That's where we started that top graph, that top equation. That's where we started our graph. For the bottom one, you think you might know where we might start it? Close. You're just missing something with that one. Negative 1, right? Remember that number to the left. So we'll go on the x-axis. We'll put a point at -1. Now, Trenton, from there, where am I going to go?
Up 4.
Up 4.
And to the right 1.
And look at that. As soon as we go up 4 and right 1, bang, we hit the other line. It's not always going to happen that way, but in this case it did. We see, there it is. Mr. Hager's going to draw the line in there. We see the point where it intersects. Right here. I'll make it nice and big in red. There it is. Someone tell me by raising their hand, what coordinate is that? Mr. Hager's getting it all set to write it up on there. What coordinate is that? Nini? 1, 3. Here's 1 on the x-axis, and then there's 3 on the y-axis. 1, 3. Now, I got to check it. All right? So, for the first one, I'm going to have 3 equals -2. 1 plus 5. Right? So there it is. All I did was, here's my x, here's my y. I took them, I plugged them in. Right? I plugged them into the original equation. Alright? X was 1, I plugged it in down here. Y was 3, I plugged it in down there. Now I'm just going to do the math. -2 times 1 is -2 plus 5 equals 3. Mr. Hager puts this little question mark. I'll do that. All right, I still got my question mark here. So -2 plus 5. I'm going to read it. So I always say take the sign of the bigger number. I know my answer is going to be positive because 5 is bigger than 2. So I'm just going to read it backwards. 5 minus 2 is 3. 3 equals 3. That works. But I'm not done because I got to check both. All right? I'm not done because I got to check both. Now, come down a little bit here. You can still see that one. Okay. So, now I got y equals 4x minus 1. Here's my possible solution. 1, 3. We've already showed you guys in the previous examples how to plug it in. I just did it here, plugging it in. Someone tell me, by raising their hand, how would I set up this equation, but now I want to plug stuff in? What would that look like? Can someone tell me? Nini?
3 equals 4 times 1 minus 1.
Correct. All right? Remember, when you have that number, when you have that x or y attached to a number, make sure you put parentheses, right? So it doesn't look like a bigger number. So now I'm going to get 3, I'm going to get 4 times 1 is 4, minus 1. Yep. And I'll get 3 equals 3. So that solution does work, right? 1 comma 3 is a solution for that system of equations. All right? Now, on your sheet, I'll scroll back down so you guys can get the rest of this. On your sheet, you're going to see an example 2b. All right? We're not going to get to that one just yet. So we want to make sure we give you guys the word problem. All right? And then what we'll do is, with the time we have left, we'll probably have you guys practice on that one. So we know before we give you guys the homework, we know what you're doing. All right? Mr. Hager's going to show. He's going to show. We're skipping 2b, and we'll go into example 3. So we want to make sure we get through the word problem, you guys. And the good thing about the word problem is, guys, we're just going to set it up. We're not going to solve it.
Yeah, the reason we're not going to have you solve it is because if you look at the numbers in it, they're kind of big. So if you were going to graph this, you'd need a really big graph to do it. So we're just going to set up the equations that we would solve if we were going to graph this.
And guys, there'll be one word problem on the homework tonight. Same thing. If we didn't expect you guys to solve it in class today, we're not going to have you solve it for homework. We're just going to have to set it up just like this.
All right, so let's just read through and see if we can figure out what the two things are we're going to solve for. Because there's always 2 letters, right? We just have to figure out what they are. Okay, so it says a contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. And then he makes another purchase, and we're assuming same price. He goes back later in the day to buy more stuff, so there's no change in the price. And that time, the contractor buys 8 bundles of shingles for $256. All right, so we got to set up 2 equations. Okay? So we need 2 variables. Okay? We always need as many variables as we have equations. So, okay, so let me write down what we're solving for. Okay, so solve. You might have to add this. For the price per bundle of shingles. Okay, that's the first thing I want to know. And I also want to know the cost for each roll of roofing paper. So solve for the price per bundle of shingles and the cost per roll of roofing paper. So you can pick any letter for now because we don't know the cost for the bundle of shingles. So what letter do you want to use to represent the price of each bundle of shingles? Okay, we could use X, that's fine. You could use S for shingles. Make sure your S doesn't look like a 5. That can throw people off. Who said X? Is that you, Antonio? Yeah, all right, we'll go with X. We just have to remember X is shingles. All right, and what do we want to use for the cost per roll of roofing paper? What letter do we want to use to represent the cost for the roll of roofing paper? Kyle? Yeah, okay, we can use Y. You could use R.
You could use S and R if you wanted to for shingles and roofing paper. You could use A and B. It doesn't matter what letters you use. Well, it doesn't matter.
All right, now the first time that the contractor goes to the store, how many bundles of shingles does he buy? He buys 30 bundles. Now, how would you figure out the cost? If he bought 30 bundles and you knew how much each bundle cost, what would you do with those 2 numbers? I heard a couple people say it. You would multiply them, right? If each bundle was $1 and you bought 30 bundles, you do 30 times $1, it would be $30. If it was $2 per bundle, you'd say, all right, I bought 30 bundles. I paid $2 for each one. I'd do 30 times 2. How are we representing the cost per bundle right now for shingles? We don't have a number. We're representing it as X. So we're going to take the number of bundles that he buys times the cost per bundle. Okay, we don't know the cost right now, but that's what we're going to figure out. Or that's what we would figure out if we were going to solve it. Now, is that the only thing that the contractor buys in the first trip to the store? Do they just buy 30 bundles of, let me scroll back up a little bit. They also buy 4 rolls of roofing paper. So does that subtract from his cost? Does that add to the money he spends? What does that do? It's adds, right? The contractor's going to spend more money.
Now guys, think about how Mr. Hager just represented the 30 bundles of shingles, right? He put 30X. How do you think he would express the 4 rolls of roofing paper? Anybody think they might know? How he might express, Josh? 4 times Y, right, good.
Yeah, because he buys 4 rolls of paper times how much it costs per roll. We don't know the cost right now, but we do know how much money the contractor spends when he goes to the store the first time. How much money does the contractor spend altogether on 30 bundles of shingles and 4 rolls of paper? How much? Yeah, 1,040. Okay, so now we have one of our 2 equations. Okay, when you're setting up a system, one isn't enough. You've got to have a second one. Okay, you've got to have a second one. And that's where that one comes in. Okay, what did the contractor do the second time they went to the store? They just bought 8 bundles of shingles. That's it. So how much did they spend on that 8 bundles of shingles? $256. But now, how would you represent 8 bundles of shingles? Yeah?
8x.
Yeah, 8x. And that's all you have to do. Those are your 2 equations you have to set up. Now, I'm not going to go through and finish it, but does anybody know how you could get x by itself here? And that would tell you the cost for a bundle of shingles?
Step.
Yeah, it would be 1 step, and then you'd know bundles of shingles are this many dollars. So I agree with this doing something to this 8, but we can't subtract it. We could subtract it if you had this. Then you could subtract it. But what do we do when the 8's right next to the x? Emma?
Divide 8.
Yeah. If you divided each side by 8, I can tell you that a bundle of shingles is $32.
But you guys, you don't have to do that.
Yeah, you don't have to finish
All we're doing
it.
is setting up. That's it.
And then once I know how much a bundle of shingles is, I could then figure out how much a roll of roofing paper is. Okay? But any questions just on the setup? Okay, that's all you had to do.
So guys, what we'll probably do is we get that next slide and kind of just gives a recap of the week. Then maybe at the end we'll give let's have them work on that 2B exam.
Yep, so we'll give you guys time to work on 2B. So Mr. Roy mentioned we're halfway through the term, which means progress reports come out on Friday. We only have 1 test. It'll be the 1 test we take on Friday.
Guys, just be careful because progress reports close on Friday. You'll get them probably next Thursday or Friday in shop. All right, you'll get them probably at the end of the day, either Thursday or Friday next week in shop. They just close on Friday.
Thursday, we're going to do an MCAS question. And for Thursday, it's important that you guys bring your Chromebook. How many people normally bring it every day anyway? Okay, just about everybody. You have to for other classes? Okay, yeah, make sure you definitely have it. Make sure it's charged because you're gonna need it for the MCAS question on Thursday, and then test on Friday. Okay. All right, so we'll give you guys a little bit of time to work on that example 2B. Kyle, what's up? Oh, no? Okay.